Hello friends, welcome to Abdemi. Today we will consider an interesting problem on locus. You know that locus is the first chapter of any coordinate geometry course. So let us see a locus problem. What is the question? Question is, if the sum of the distances of a point from two perpendicular lines in a plane is 1, then its locus is square or circle or straight line or two intersecting lines. That is the problem. Now, first of all, they are saying that a point is moving in a plane in such a manner that its sum of the distances of the point from two perpendicular lines is unity. So first of all, let us consider two perpendicular lines and let us call them coordinate axes. So two perpendicular lines, we assign them as x-axis and y-axis. Now consider an arbitrary point P. Incidentally, here the point P is kept in quadrant 1 of the coordinate system and its coordinate is hk. Now we know in locus problem the point moves under a condition, moves under a constraint. Here the condition is that the point is such that its distances from two perpendicular lines, in this case these are coordinate axes, sum of their distances is 1. Now what is the sum of the distances of the point P from the two coordinate axes in this case? Apparently it is very clear that here h is the distance of the point from y-axis and k is the distance of the point from x-axis. These are the distances. So distance is h plus k. Because the given condition for the problem or constraint of the problem is that the sum of the distances from two perpendicular lines, we have taken those two lines as x-axis and y-axis, and this sum is unity always. Point is moving in a plane in such a manner that this distance is always unity. So I can write the sum of the distance in this case when the point is in quadrant 1 is h plus k. So what is the sum of the distances of the point P from the two coordinate axes? Is it, the question, the moot question is it the sum of the points x coordinate and y coordinate? Is it the sum of the points x coordinate and y coordinate? If the point lies in first quadrant, then definitely it is so. The distance d is h plus k. But when the point comes in quadrant 2, say consider a point -1 plus 1, which is at quadrant 2. See here, this distance and this distance, this is unity, this is unity, and since the point lies in second quadrant, x coordinate is negative but the y coordinate is positive. So if you sum the x coordinate and y coordinate of the point, it becomes -1 plus 1 is 0. But definitely it is not 0. So sum of the distances of the point from two coordinate axes when the point lies in second quadrant is definitely not pure sum of the x coordinate and y coordinate. Similarly here, when the point is say -1, -1. The sum of the distances is -2, but actual distance, sum of the distance should be 2. So I cannot say that the sum of the distance of the point, sum of the distances of the point from x coordinate, x axis and y axis is sum of their coordinates. What it is, that is the moot question, that is the main point of this problem we have to critically look into. Let us go to this slide. See, let us discuss the situation when the point lies in any of the 4 quadrants. When the point lies in first quadrant, say point is at P, say, whose coordinate is AB. A and B are positive numbers. Here in first quadrant, both coordinates are positive, and definitely the sum is A plus B. Okay. Now consider the point lies in second quadrant. Then its coordinate can be written like this, -CD, where CD are positive numbers. C and D are positive numbers, because in second quadrant x coordinate is negative and y coordinate is positive. And here what is the distance? Distance is actually C plus D. Sum of the distance is C plus D. And C plus D I can write like this, negative of negative C plus D. Carefully note. So it is negative of the x coordinate plus D. X coordinate is actually negative C. C is a positive number, and D is the y coordinate of the point when the point lies in quadrant 2. And sum of the distances of the point from the coordinate axis, which are the perpendicular lines, it is actually negative of the x coordinate plus y coordinate. Similarly, when the point is at position R, whose coordinate is -E, -F, E and F are positive numbers, and you know in third quadrant both the coordinates are negative. Here the sum of the distance is E plus F, because this much distance is E, this much distance is F. So when I talk about distance, distance is a pure positive quantity, so it is E plus F. And here what is that? It is negative of the x coordinate plus negative of the y coordinate. So here it is like this. E, F, remember, they are positive quantities. Similarly, if the point is at position S, which is in fourth quadrant, here the x coordinate is positive, y coordinate is negative. Say for example, the coordinate of S is G, -H. G, H are positive number. Here the sum of the distances of the point S, which is lying in quadrant 4, from the two coordinate axes, for that matter from the two perpendicular lines, it is actually G plus H is equal to G plus negative of negative H. So how do I generalize? If the point lies in 4 different quadrants, because if the point moves in this plane of the whiteboard, then either it will lie on quadrant 1 or quadrant 2 and quadrant 3 or quadrant 4. And definitely we cannot say the sum of the distances of the point from the coordinate axis is equal to its x coordinate plus y coordinate. It is not like that, we have seen here. Now what happens actually? How do I write this expression? Sum of the distances of the point from two perpendicular lines. These perpendicular lines are actually, in our case, we have taken them as coordinate axis for sake of brevity. Now what is the general expression of this quantity? Because this is the condition of movement of the particle, you can say the point is moving in this plane in such a manner that the sum of the distance of the point from two perpendicular lines is constant and its value is unity. So how do I express this condition mathematically? Okay. So in general, if the point RS is an arbitrary point, in general if RS is an arbitrary point in a plane, then the sum of the distances of the point from the two coordinate axes is mod R or absolute value of R plus absolute value of S. Why? Because you know, when I talk about absolute value, mod n is n when n is 0 or positive number, and mod n is negative of n when n is a negative quantity. So you know, this is the definition of absolute value of a quantity. So when I say that a point's coordinate is, say for example 3 minus 1, that means mod 3 plus mod minus 1. So it is 3 plus 1, 4, because mod 3 is 3 and mod minus 1 is 1. So 3 plus 1 is 4. When the point lies, say in third quadrant, coordinate is minus 2 minus 1, then what is the sum of the distances of the point from the coordinate axis? It will be mod negative 2 plus mod negative 1, which is 2 plus 1 equal to 3. And when the point lies in second quadrant, say minus 1, 5. So what will be the sum of the distances? It will be negative 1's mod plus mod 5. So it will be 1 plus 5, 6. So the correct expression for sum of the distances of the point RS from the coordinate axis would be mod R plus mod S. If you understand up to this point, then you are almost through with this problem. I think this is clear. And remember, what is the definition of mod n? Mod n is n when n is greater than equal to 0, and mod n is negative n when n is less than 0. That's why when I write mod minus 1 is actually inside mod the quantity is negative, so it is negative of negative 1, so it is positive 1. Similarly, mod minus 5 is the quantity inside the mod is negative, therefore it is minus of minus 5, which is plus 5. So hope up to this point the things are clear. All right, now let us come to the problem. So we have considered the two perpendicular lines as x and y axis of the coordinate system, which is lying in this plane. Now at any moment the point is at hk, I assume. The point is moving in this plane, but moving under a condition that the sum of the distances of the point from the coordinate axis is always 1. And how do I write this phrase mathematically? Sum of the distances of the point from two perpendicular lines. If at any moment the position of the point is hk, then definitely this condition is written like this: mod h plus mod k equal to 1. Now this is the condition of movement of the point in this plane, and in this condition, you know the locus problem, locus equation to the locus is satisfied by all points, all coordinates of the point on the locus. Therefore the equation of the locus or the locus of the point is replace h by x and replace k by y. So it is mod x plus mod y equal to 1. But what does it represent actually? Mod x plus mod y, it is not a conventional equation of straight line. Had it been x plus y equal to 1, I could easily say that this represents the equation of straight line. But here it is quite unconventional. It is mod x plus mod y equal to 1. Now, what this equation represent in first quadrant? In first quadrant, both x and y are positive, So it becomes mod x plus mod y becomes x plus y equal to 1. Okay, and x plus y equal to 1 is the equation of straight line which has intercept on x axis at point 1 0 and intersects y axis at the point 0 1. So this is 0 1, this is 1 0, and this is the line AB which is represented by this equation. And what is the slope of this line? If I compare the equation with standard equation of straight line, then you know, if y equal to mx plus c is the equation of a straight line, then m represents the gradient of the straight line. And in this case, what happens? In this case, AB becomes negative of 1. So this is a straight line whose gradient is negative 1, and point of intersection of the line with x axis is 1 0, point of intersection of the line with y axis is 0 1. Now what does this equation represent in second quadrant? In second quadrant, x is negative, y is positive, and when x is negative, when x is less than 0, we know mod x is negative of x. Mod x is negative of x. That we know. Therefore, here I write second quadrant, but y is positive. Therefore, from this equation I can write negative of x plus y equal to 1. Negative of x plus y minus x plus y equal to 1 is also representing a straight line whose intersection or which interconnects or which intersects x axis at minus 1 0 point, because minus x plus y equal to 1, it intersects x axis as negative 1 0 and intersects y axis at 0 1. So these 2 points are the point of intersection of the line on y axis and x axis, and this line is confined in the, we should consider that part of the line confined in quadrant 2. And what is the slope of this line? Slope of this line, you see, it is 1. So MAD is 1. AD, this straight line represents this equation, or this equation represents the straight line AD. Now what this equation represents in third quadrant? In third quadrant, both x and y are negative, and therefore in third quadrant this equation represents negative x, negative y, minus x minus y equal to 1. And minus x minus y equal to 1 is also representing a straight line, and its gradient is negative 1. Just compare with y equal to mx plus c format, and negative x negative y equal to 1, it intersects x axis as negative 1 0 and intersects y axis at 0 negative 1, and these points are D and C, and the line connecting D and C is DC, and whose slope is actually negative 1. And finally, what this equation represent in fourth quadrant? In fourth quadrant, x is positive, y is negative, and therefore mod x is x and mod y is negative of y. So x minus y equal to 1. X minus 1 y equal to 1 is also an equation of straight line which intersects x axis at 1 0 and intersects y axis at 0 negative 1, and the gradient of the line is actually plus 1. So this x minus y equal to 1 represents this straight line BC whose gradient is plus 1. So you have seen that the single equation what we obtained from the condition mod h plus mod k equal to 1, unfolds into 4 different state equations of straight lines in 4 different quadrants of the plane: first quadrant, second quadrant, third quadrant, and fourth quadrant. And what is the character of these lines? You see, AB, the length of AB is actually connecting point A and B, and length is √2. Similarly, length of this line AD is also √2, because it is always 1 square plus 1 square under square root. So it is √2. Here also you just find the distance between point D and C, you find it is √2 again. 1 square plus 1 square under square root, so square root of 2. And here also you see the distance between these 2 points is again √2. Moreover, since MAB is -1, MAD is +1, so line AB and line AD, they are perpendicular to each other. This angle is 90 degree. MAD multiplied by MCD is -1, so these two lines are perpendicular, because you know the product of gradient of two straight lines which are perpendicular to each other is always -1. And similarly, gradient of CD multiplied by gradient of BC is -1. So this angle is also -90 degree. And gradient of AB and gradient of BC is also -1. So this angle is 90 degree. So all the interior angles of this quadrilateral A, B, C, D is 90 degree, and their sides are equal and length is √2. Therefore, A, B, C, D is a square. That means if a point moves under a condition that its distances, sum of the distances from the coordinate axis is always 1, then it happens to lie on the square ABCD, whose length is √2, side length is √2, and the shape is like this. Alright, therefore, the locus of the point under such condition is actually a square, and therefore square A is the correct answer. So the moot question of the problem, moot point of the problem was to write the condition properly, which is mod H plus mod K equal to 1. This is the most critical point of this problem. And what does this translate into? When I find the equation of the locus, it translates into mod X plus mod Y equal to 1. And mod X plus mod Y equal to 1, it is a equation involving the modulus of X and modulus of Y, or absolute values of X and absolute value of Y. It unfolds into 4 different equations: X plus Y equal to 1 in the first quadrant, minus X plus Y equal to 1 in second quadrant, minus X minus Y equal to 1 in the third quadrant, X minus Y equal to 1 in the fourth quadrant. And these straight lines, they constitute a square whose side length is √2. And therefore, the locus of the problem, locus of the point is a square. I hope you have understood the problem. It is very interesting problem, and if you understand the concept behind the solution, then you can crack many such interesting problems related to locus of a point. Okay, thank you for your listening. Thank you very much.